Hi, this is Tom Brower from the Hydrologic Engineering Center. In this video, I'm going to demonstrate some tools that can help with model calibration. The calibration aids that I'll demonstrate today are the element results, the continuous calibration aid, the statistics report, and the statistics plot. The element results summary table and graph are integral to HMS. Anytime I have observed flow for an element, the graph will show both observed and computed flow, and the table will provide goodness of fit metrics such as Nash-Sutcliffe efficiency and percent bias. You can see here I have the Wenatchee near monitor junction selected, and for that junction I have observed flow. I've already computed the simulation run. If I view the graph, you can see that I have observed flow in black and computed flow in blue. This gives me a graphical notion of my calibration. I can also view the summary table, and because I have observed flow selected, I get goodness of fit metrics such as Nash-Sutcliffe efficiency and percent bias. I can also compare peak discharge and volume. Some of the pros of this approach are that it's pretty easy to access. It's built into HMS. It also automatically updates with each compute. Some cons is that there's no ability to change the computation time interval for the statistics. The statistics are computed at the simulation time interval. This causes discrepancies when the observed data is in a different interval than the computed results. Another con is that this is only a single point in view at a time. The only way to view multiple points at one time is to open multiple results windows. The next calibration tool that I will demonstrate is the continuous calibration aid. The continuous calibration aid was built for a modeling project on the Columbia River where the calibration events were entire water years. For this case, it was helpful to be able to quickly view a hydrograph based on monthly average flow. The simulation was also performed at a one-day time step, while the observed flow was often hourly. The continuous calibration aid allows us to select a statistics time interval that is different from the simulation time interval. Here you can see the continuous calibration aid. I've selected a simulation DSS file and path, an observation DSS file and path, and an analysis period start date and time, end date and time, and a statistics computation time interval. The statistics computation time interval can be different than the simulation time interval that was used in HMS. Once I have this parameterized, I can click Compute. On the Statistics tab, I'll have summary statistics such as Nash-Sutcliffe efficiency, root mean squared error, standard deviation ratio, percent bias, and coefficient of determination. These statistics have been computed at the statistics time interval that was specified in the continuous calibration aid. I also have a monthly average tab that gives me a runoff hydrograph that is based on monthly average flow. So the pros of the continuous calibration aid is that it gives me the ability to change the time interval for the statistics to something that is different than the computation time interval that was used for the simulation in HMS. It also gives me the ability to change the computation time window for the statistics. I can optionally use a subset of the window that was used for the simulation. It rapidly performs cyclic analysis for the continuous simulation. Some cons of this tool is that it's not a tight integration with HMS. The calibration aid is a standalone utility. It's also for a single point. The only way to view multiple points at one time is to open up multiple instances of the tool. And then you must recompute this tool with every compute in HMS. The next calibration tool that I'll demonstrate is the statistics report. To generate a statistics report in HMS, you must have already computed the simulation run. The statistics report is available from the Tools Reports menu. Here I can select the simulation run and a destination to write the report. The report format is HTML. Now my report's been created and I can browse to it. You can see that in my Bayesian model, I have many computation points. So one of the nice features of the statistics report is that it gives me a consolidated view of my computation points in the Bayesian and summary statistics for each. One of the cons of this approach is there's no ability to change the computation time interval for the statistics. The statistics are computed at the simulation time interval. This can cause discrepancies when the observed data is in a different interval than the computed results. And then I must regenerate this report every time I do an HMS compute. Finally, I'll talk about the statistics plot. There's currently no automation for the statistics plot, but it can be generated in a GIS if you're willing. And the statistics plot subbasins or calibration points are colored based on their performance for a given summary statistic. Pros of this approach is that it gives a spatial notion of calibration. Because the statistics plot is not currently automated, it is typically something that we only do for reporting purposes once the calibration is complete. This concludes the presentation on model calibration aids. For more resources on HEC-HMS, check out the HEC-HMS documentation website.